Many of our related rates problems might involve concepts of distance. So in this problem, the police are after you, but you don't know it yet. You are currently 30 miles east of Wabash, and the police are traveling due south towards Wabash at 45 miles per hour. How fast is the distance from you and the police decreasing? And I should add a condition here. When the police are, we'll say, 100 miles away from Wabash. I could have made that problem a little harder, but this is our first distance problem. So, like we did in the previous problem, we're once again going to break this up into a general situation and a specific moment in time. So what's our general situation? We have, here's Wabash, and you currently are 30 miles east of Wabash, and you're not moving anywhere. So generally, this distance is going to be 30 miles from you. The police are traveling, so their distance is changing over time. We'll just call it X for the sake of argument. There's a little police car for you. And then we're interested in the distance between the police and you. We'll call that Y. So this gives us a general formula that x squared plus 30 squared, using Pythagorean theorem, x squared plus 30 squared equals y squared. So we have a formula relating the distance from the police to Wabash, which is something that we know, and the distance from me to the police, which is another thing we know. So let's go ahead. The other thing we did is we took the derivative to get a formula not just relating the distance from me to from the police to Wabash and from the police to me, but also relating those rates of change. So we'd have that dx over, we take the derivative of each side. Derivative here is going to be 2x times dx dt, because we have to think about a little chain rule, because everything's a function of t. 30 squared is just a constant, so I'll just leave that as an equal sign. And derivative of y squared is going to be 2y times dy dt. You can actually simplify this a little bit. We'll just get x times dx dt equals y times dy dt. And that has our formula relating the distance of the police from Wabash, from me to the police, and also the rate of change of the police from Wabash and the rate of change from me to the police. And what we know is we know the rate of change of the police from Wabash, and we're trying to find the rate of change from me to the police. So now we're going to go to our moment in time and use the information we have to solve the problem. So at this specific moment we're given, we have that the police are 100 miles from Wabash. I am still just 30 miles from Wabash. And the other thing we have is that they're traveling towards Wabash at 45 miles per hour. So I'll draw my little picture there. So what does this tell me? Looking at my original picture, this tells me that x equals 100. I don't have y exactly yet, but we can find it. We also know that dx dt, this distance of x is shrinking at a rate of 45 miles per hour. So it's going to have a rate of change of negative 45. And dy dt is what I'm actually solving for. So you might notice that I have two question marks, which might seem like a problem. But the good news is I can actually find y using this equation. So we're going to find y using original equation. We have that x squared plus 30 squared equals y squared. Well, we know x is just 100, so we have 100 squared plus 30 squared equals y squared. Oh, that's going to be something like 10,000 plus 900 equals y squared. So we're going to get that y equals the square root of 10,900. That's lovely. So we have y equals the square root of 10,900, and we're probably just going to leave it like that because I don't feel like pulling out my calculator. But you could, of course, plug it into a calculator, figure out what that number is. So now I have x, y, and dx dt. Now I'm ready to go ahead and use my related rates equation to solve for dy dt, which is the rate of change between me and the police. Or you and the police, I suppose. So we're going to set that up. We have x times dx dt equals y times dy dt. In this case, x equals 100 times dx dt equals negative 45. Y equals the square root of 10,900, and we don't know what dy dt is. But all we need to do to solve for dy dt is divide by the square root of 10,900. And that's going to give us something like dy dt equals negative 4,500 over the square root of 10,900 miles per hour. So they are moving closer to you. We can guesstimate square root of 10,900 is a little bit more than 100. So it's at a little bit less than 45 miles per hour. But it's, relatively close. So there we go. We now have the rate at which the police are getting closer to your location. It sounds like you should probably get on the move.